I'm very pleased and very honored to be a part of this, and I'm going to talk about mobile robots in the outdoor public domain. My background in doing this is I have a Bachelor of Science in Mechanical Engineering, I have a Bachelor of Science in Education Science. It might sound weird, but I'll come back to that, and then I also got an MBA in Economy. I've been a user of powered wheelchairs since 1986, so I have 160,000 hours of experience in driving vehicles like that. So what can you use that for? Well, especially when you want to go outside and drive with mobile robots, there are some circumstances that you have to be aware of. We have our robot company in Aarhus, Cable Robotics. We are 14 people. And we are developing this robot that we want to get to the market here in the first quarter of next year. Our vehicle is visual in the way that it's very precise in the steering. It has good terrain adaptability, long range, and we have a very good patent for it. What you can see here is the vehicle and what the patent covers, and that they got front wheel and back wheel that can turn simultaneously, so it can rotate on the spot. And then it's also very good at adapting to climbing curves, climbing hills, and so on. Our patent covers already, you will say, most of the important countries in Europe, Japan, Australia, China, Israel, and it's in the national case of Canada and South Korea. And the patent covers all kinds of vehicles. I'll just show you a video so you can see what the application that we're working with now can do. We're not doing the final application. We're making a mobile robotic platform. And that means that it's a B2B, and it could be used for a lot of different things. It could be for picking up cigarette butts in the city area. It could be picking up gum. It could be last mile delivery. There are lots of stuff. Just let you have a look at this. It doesn't really care if it's on road or it's on slopes, driving on sand. It does a lot of different stuff. Later, we reckon that we will also be doing other sizes of vehicles, and also working with putting a trailer afterwards, so it can carry even higher loads. This, of course, needs to be legal, and we've been working a lot with the Danish government to get a new legalization in place, so we can start testing these mobile robots. And if all goes well, we should be able to do that from the 1st of January 2021. And that also means that actually I have tried to make it similar, because there are a lot of good knowledge from especially driving with with powered wheelchairs, that we follow some of the same rules. That means that on sidewalks you're allowed to drive 6 kilometers an hour, otherwise you have to gear down on the bike lane, and we're not allowed to do that. 15 kilometers an hour would be okay if there were empty park lots, areas like that. So it is a test law. It also needs to be sure that if anything happens, that people that get hurt, if that should happen, most certainly we don't hope that will happen, that the tester would have to be responsible for that. But I think that is also important, and also included in the test law, is that at all times when you test these mobile robots, you have to have somebody that could take over. And that could be in situ, or it could also be from another place. But again, from another place, that means as we are driving in Denmark and Danish laws apply, they have to be in Denmark. We need a kind of facility, as we see it, where people can take over these robots. And there will be a lot of different companies working with these mobile robots. It could most likely be a good idea to make this as a kind of service that producers of mobile robots could produce. Yes, and the thing is that even though that these robots have to drive in the street, we of course have to be sure that the navigation is right. And so there are two challenges about navigation in urban areas. We in Aarhus, we are a part of the CCAS system. The CCAS system is set up by DTU and the municipality of Aarhus, and also the Danish state. But even though you have good GNSS possibilities with RTK at good in the open area, we can have a precision of ±1 centimeter. But when you get close to buildings, you will have a phenomenon called multipath. And that means that the signals that come from satellites tend to skip back and forth between buildings. That means that suddenly you can have a signal that points at you as somewhere else that you really would like to be. What we're trying to do with mitigating that is, for instance, trying to use GIS as the geodetic data that are very, very good in Denmark, and they try to use that as what we would call something called pre-SLAM. SLAM is simultaneous localization and mapping, and that means that before we even drive, we would like to have a good understanding on where we're going to drive. Normally with SLAM you have to drive the whole route first before you can let the robot loose afterwards. So that's what we want to do. We want to combine visual map with AI with precision. And there are of course other safety things that we have to be aware of through geofencing, and we also have to be aware of moving objects. And we have something that we call soft and hard safety that I'll come back to. So another thing that we're also looking forward to is 5G. That's official also due to we should get the latency down. It's not a good thing that if we should have one of those pilots that I talked about before that should help driving the robots. Should look out of the cameras in the robot that we have a latency time of after a whole second. That would certainly not be helpful. We are trying to keep the AI as simple as possible, and we would prefer to try to use vectographic change the thing that we see onto vectographic, and then compare that to these areas. Level of possible autonomy. Like I like to say, robots are dumber than mice. Mice can do a lot of different things. Robots are actually quite limited to the AI that they're using right now. And that's also to do of the complexity, but also the need to understand the context. What context is the robot in right now before it can use the adequate AI to solve the problem. Well, there's a lot of difference of driving on a sidewalk and a bike lane or crossing a road. It's three totally different tasks. So we have to find out what kind of AI are we going to use here. The top window is a robot in US that kind of drowned itself, fall into the water due to it was not configured in a way that it could sense that that was a bad way to go. And again, we might think that we know what to do, but there are black swans and there are broken traffic lights, and we might have made some robots that are capable of seeing traffic lights, but what if they're broken or it doesn't work? And that's what I come back to again, that we need a kind of a robot pilot support center inside the borders of Denmark. And now, as I said, I'm a user of a power wheelchair, and a lot of actually a lot of other power wheelchair users that could also be pilots in a situation like that, just as an example. But anyway, it's more than that, because when you have these robots out and driving, of course you need hard safety in the way that you don't want the robots to drive into anything. But you also need, okay, sorry, I'll let pass to that. You also need something called soft safety. I'll get back to that, sorry for that. Regarding this of the artificial intelligence, to understand that is when you learn machine learning or artificial intelligence, it's very, the thing that the computer had to learn is quite what you call it, restricted. You can't have all these different complexities at the same time. Okay, sorry. Yes, hard safety. The safety, normally we talk about hard safety in the way that you have sensors that will ensure that you don't drive into things, and that's good enough. That's the right thing to do. But another thing that we don't talk that much about is the soft safety. And that's actually to make people and animals feel safe when they are near or passing a mobile robot. Like an old lady comes with a rollator and meets this robot for the first time. We want to be sure that she doesn't get scared of it, because one thing is to drive into it, but another thing is that if she gets scared of this robot, might even step out to the car and step out on the road. She might get hit or something. So we're working with these what we call intuitively understandable intention markers. So the robot has to show its intentions in a way that it's intuitively understandable for a person that have never seen this robot before. And that covers a lot of different things. It covers how the robot looks visual. It's not supposed to look aggressive in any kind. It's not to accelerate in an aggressive way. It's good if you can see the wheel turns, because if you can do that, you can also predict which way it's going. It also includes using colors. Some kind of colors will tend to be more, what do you call that? Make you more unsecure than other colors, and also the sounds. That's also very important. And I normally give an example. The place where we had a company before, we were on a large parking lot, and when you had to go out of that parking lot, to the left there was a light, a traffic light right away, and from the right there was the highway, and in the rush hours the lanes were fully occupied. You could not go to the left if you had to follow the normal traffic rules. The only way you can get out was if you get eye contact with some of the car users in the row, and then kind of let you out. And when you have shark teeth and you're not allowed to get out in any other way, then you really have to use this icon. That's what we want to do with our robots also. So this is what I would like to say, and then I'm ready for some questions.
Thank you very much. Thank you very much, Miss. I will now bring you back into the room so that people can see you. Just a second. Yeah. Questions for Miss, please? John?
Hi, Mads. Thank you for a very interesting presentation. How, in more details, do you envision that these intention markers could look like and operate from your robots?
Can you please ask the question again?
The intention markers that you are talking about,
Yes.
how would you envision that they would look like on your robots? Would it be cartoon eyes or blinking lights, or do you have any ideas that you would like to share with us?
Yes, we'll certainly like to do that. Our company's name is called Capra. Capra is the main name for goats, and what does that do to that? It has a lot to do it, because a goat is something you might like to pet it, you don't want to pick it. And that's the same thought that we need about our robots, that it have to be serious, not cartoon-like actually, because then people might tend to do something else, and that's also an intention markers. To make something that's friendly, seriously, not aggressive, and stuff like it. It might sound floppy, but it's all covered in the design phase. Also, just a simple thing like a robot, as we see it, has to have a direction, because then you will know what way it's most likely it's going to go. And that's also incorporating our intention markers. Also that it has some kind of eyes that are visible, but not again cartoon-like. It might be camera, just something that you, okay, I can see it sees me. So now I'm more assured that it will not run into me. Another intention markers that light, the usage of light, of course we would use what we call a blink light for turn light left and right and stuff like that, brake light and headlight for showing also direction. So it is a lot of different things, and we're working with both with University of Aalborg, University of Aarhus, DTU, and even CCAS. And also DTU on these different kind of intention markers, because they are different. Again, sound, lights, colors, behavior, shape. So.
Are you satisfied?
Yes, thank you very much. And if there's time for one additional question?
Sure.
Yes. I would like to know if you could share your ideas of what would become the most important markets for your product. You mentioned briefly surveillance of properties, but would you imagine it being used in any other major market segments?
As I see it, mobile outdoor robots is an emerging market. And it could be difficult to say what especially would be the greatest market. Again, what we try to do is to provide a platform for other companies to build their solutions upon. So, but I'm very sure that things like cleaning in the urban area would be important, last mile delivery, but there are so many different things. Also, maybe going out or indoor. Right now we're working with a lot of technologies that are looking into security and surveillance, but we're also looking a lot of other places. So yeah, we're pretty open for ideas, but again, we are the enabling platform. We're not the ones that do the actual applications.